Here is an explanation for the answer to final exam question number 78, found on page 677 of Teach Yourself Electricity and Electronics, 5th edition. We're told that we have a hi-fi amplifier, high fidelity amplifier, and we apply a perfect sine wave input at 1000 Hertz. A pure sine wave, which looks like that. If we, on an oscilloscope, it looks like a graph of the sine function, which is a nice, neat wave. We get an output that's a sine wave, or at least it looks like one if we look at it on an oscilloscope, that has a lot greater amplitude, also at 1000 Hertz. Now, suppose that we connect the output of the amplifier terminals, which is already connected to a speaker, to the vertical input of an oscilloscope. And we connect that's the output signal that we connect to the input, the vertical input of an oscilloscope. We might draw that like this. We put the output signal here to the vertical input of an oscilloscope. We connect the input signal to the horizontal input of that same oscilloscope. So the input signal maybe would go, we might represent it like this. It's a little bit crude, but you get the idea. The input signal then appears along the horizontal axis and causes a deflection of the wave back and forth horizontally. The vertical signal, on the other hand, causes a vertical up and down deflection on the scope. The input signal is a lot lower in amplitude than the output signal. But if they are in the same proportion at all times, that is to say there's no distortion produced by the amplifier, then as this signal goes out to the right like this, the output signal will go up in direct proportion at all times, and similarly, when this signal goes negatively, this one will go negatively in the same proportion at all times. As a result, we will see a straight line on that display. Now, if we end up with an amplifier that produces distortion, we're going to be able to see that pretty easily by using this arrangement. We may not see it that easily if we just look at the waves on an oscilloscope with time going horizontally and amplitude going vertically like that. We'll see what look like sine waves, but there can be a considerable amount of distortion, and we won't be able to see that. But we will be able to see it pretty clearly in a case like this. In a case like that, this is a typical example of what distortion might look like on an oscilloscope. When we have a perfectly straight line, though, as we did before, we say that the amplifier has excellent linearity. And in fact, that is where the term linearity or linear comes from in an amplifier. It means that the output versus input function at all points in time instantaneously is a straight line. It's linear. So the correct answer to this particular question is B, as in bravo.